Hello everyone. Today we are presenting a project on crime data analysis and visualization using Apache Spark. We'll be exploring crime patterns in Chicago to uncover insights that could help improve public safety. Urban crime is a major challenge for any large city. Traditional methods for analyzing crime data often can't handle the massive volume of information. Our project tackles this problem head on by using a powerful big data framework, Apache Spark, to process and analyze Chicago's extensive crime dataset, looking for patterns that aren't obvious at first glance. Our goals were clear from the start. We wanted to collect and clean Chicago's crime data, explore it to find key trends, and then use advanced geospatial and clustering techniques to pinpoint crime hotspots. A key objective was also to stimulate real time crime monitoring, ultimately aiming to provide actionable insights for urban safety. To achieve this, our primary tool was Apache Spark, which was essential for handling the large-scale data processing and running complex queries. We used Google Colab as our development environment and Matplot library for creating our visualizations. Our process involved five main stages. We started with data exploration and cleaning in Spark. Then, we moved to a detailed analysis of crime frequencies and temporal trends. The core of our work was in geospatial analysis, where we used techniques like convex hulls to map crime zones and clustering algorithms to identify hotspots. Finally, we use Spark's structured streaming to stimulate how a real-time crime monitoring system would work. Now, for our results. The analysis quickly revealed the top three most frequent crimes in Chicago: theft, battery, and criminal damage. So, as you can see from the bar chart, theft is by far the most common. We have also observed that while narcotics related crimes have seen a decline, domestic incidents have remained steady. So, this gives a clear picture of what type of crimes are most prevalent across the city.
Our findings also show clear pattern related to time and location. The first graph, which is crimes per month with number of crimes on the y-axis with months on the x-axis, show consistent peak in the summer month from June to August. We also saw a spike in the crime like theft and assault during the evening hours. Also, the most common location for crime are public streets, followed by apartment and residences, as seen in the second graph on the right side, which is plotted against the location with the number of crimes, and the graph is named as top 10 locations for crimes. This confirms that both public and private spaces are significant hotspots for crime in the Chicago city. These results confirm established theories that crime is heavily influenced by location and opportunity based on the graph data or the graph result that we saw in the previous slides. For instance, the high concentration of thefts in commercial areas points to a need for better surveillance. However, we did face some challenges. The public data set had missing records that required careful cleaning, and our real time analysis was a simulation. This highlights the importance of data quality for this kind of work and for better data analysis. In conclusion, this project successfully demonstrates how Apache Spark can be used to effectively analyze complex urban crime data in major states. We identified the most frequent crimes, pinpointed when and where they are most likely to occur, and confirmed that downtown and entertainment districts are persistent high risk areas for such crimes. Finally, looking ahead, this work could be expanded significantly. The next step would be to integrate other datasets like weather or public event, build predictive forecasting model, and ultimately develop real-time monitoring dashboard that could be deployed to law enforcement agencies to help them make more informed data-driven decisions, which would help and make the society crime-free. Thank you for being around for this presentation.